In this video, we'll graph the hyperbola y equals 1 divided by 2 minus x plus 2, and we'll state the maximal domain and range for the function. So the first thing we can do for this is get it in a slightly better form so that we know exactly what's been transformed. So what we're going to do is we're going to take the negative out from the x and have x minus 2 on the bottom line, and we'll still have the plus 2 at the end of the function. So when it's in this form, it's a little bit easy to see what transformations have gone on. So the first transformation that occurs is a reflection in the x-axis, and that's because of that negative symbol there. We also have it being translated 2 units in the positive x direction because we have x minus 2, so when you take the 0 of that bracket, you get x is equal to positive 2. And it's also been translated 2 units in the positive y direction because of the plus 2 term at the end. So with this in mind, we have a rough idea of what's happened to the asymptotes of this graph. So the first asymptote occurs at x equals positive 2. And that's because if we put in positive 2 to this equation, we have y equals 1 divided by 0, and 1 divided by 0 is undefined. So the function isn't defined at that point either. The next thing we know is that the horizontal asymptote has been moved up 2 units as well, and that's from the plus 2 at the end of the equation. So across here we have y equals 2. And now what we can do is we can find the axial intercepts. So the first one we can find is the y-intercept. So the y-intercept occurs when x is equal to 0. So subbing x equal to 0 into the equation, we have y equals 1 divided by 2 minus 0 plus 2, which gives a half plus 2, which is 5 on 2. 0, 5 on 2 is that point there. And next we can find the x-intercept, which is where y is equal to 0. So if we sub y equal to 0 into the equation, we get 0 is equal to 1 divided by 2 minus x plus 2. Subtracting 2 from both sides of the equation gives negative 2 is equal to 1 divided by 2 minus x. Then if we multiply both sides of the equation by 2 minus x, we have minus 2, 2 minus x is equal to 1. Dividing both sides by negative 2 gives 2 minus x is equal to negative a half. And now if we subtract 2 from both sides, we get negative x is equal to negative a half minus 2. So negative x equals negative 5 on 2. And multiplying through by the negative, we get x is equal to positive 5 on 2. So y-intercept was 0, 5 on 2. And our x-intercept is 5 on 2, 0. And that occurs just here, which is 5 on 2, 0. So because it's reflected in the x-axis, we've now got the parabola in the bottom right and the top left corners of the asymptotes. So now if we have a look at our function, the domain in very basic terms are all the x values available to go into the function, so all the x values allowed. So for this, the maximal domain is all the real values excluding 2, because as we said before, if we put 2 in, we get 1 divided by 0, which is undefined. And the range of the function is all the y values that come out once we've subbed our x values in. So for this, we have a range that is the entire real number set, again excluding 2, because there is no x value that I can put into this bit I'm highlighting in yellow to get it to equal 0. So we can never have y equals 2, which means the range excludes that value. So on this slide, we have a computer-generated graph of the hyperbola, and we can see the vertical asymptote at x equals 2 here, and the horizontal asymptote of y equals 2 over here. The x-intercept occurs at 2.5, which we found before, which is the same as 5 on 2, and the y-intercept of 2.5 or 5 on 2 here. And over on the right-hand side, our domain and range, which we found on the previous slide.